Hello kiddos! So today I want to work with you on the ideal gas law. We're going to go through a couple of problems. I'm going to work through the first two problems here with you, and then your assignment is to complete the other three. Now if you look on the bottom of the paper, ta-da! They're the answers. I know the answers. I put them on the paper. I'm not going to grade you on the answers. I'm going to grade you on whether or not you plugged everything in the correct spot, your work. So you have to show the work. So if you simply put the answers, you're going to get it wrong. You have to show your work. Okay, so I'm going to go through number 1 and 2 with you, and then you'll be on your own for 3, 4, and 5. Alrighty, so let's get started. So this is all ideal gas law. This is all going to be ideal gas law. So here is the equation we're going to be using. Okay, PV equals nRT. That's our equation. So let's read this problem. If I have 4 moles of a gas at a pressure of 5.6 atmospheres and a volume of 12 liters, what is the temperature? So let's start plugging it in. P is for pressure. So which value am I going to plug in for P? Let's read the problem again. I have 4 moles of a gas at a pressure of 5.6 atmospheres and a volume of 12 liters. What is the temperature? So for pressure, we should be plugging in 5.6 atmospheres. That's our pressure. We can cross that out. V is for volume. Volume. 12 liters. So V, we're going to plug in 12 liters. That's our volume. We can cross that out. And then N stands for number of moles. 4. 4 moles. I can cross that out. Now here's the R constant, okay? I gotta plug in a number for R. I have 2 possible choices that I can use for R. How do we know which one to pick? Well, look at the units of pressure the problem gives you. That's how you decide. Look at the units of pressure. What is the units of pressure that we have in our problem? Atmospheres. So we look at our R constant and we use the one that has atmospheres in its unit. Which one has atmospheres as pressure in the unit for R? That's right, it's going to be this one, 0.0821. So let's plug that in. 0.0821, okay? Liters times atmospheres over Kelvin times mole, okay? This whole long thing here, this is just a unit for R. That's all that is. That's just the unit for R. That's just a unit for R. That's all that is. So now we need to plug in something for the last variable. The last variable is T. We need to go plug in something for T. Now the problem is asking us to solve for temperature. The problem is asking us to solve for temperature. So I'm going to put T. Okay, now here is everything plugged in. And now if you want to check your work, that's another reason why I put the answers on the bottom, so you can check your work. You will get your calculator. Okay, and you would plug all these numbers in your calculator, work it out, and you should get 204.6 Kelvin. 204.6 Kelvin. So on the calculator, I'm going to write out exactly what you would type in the calculator. Okay, 5.6 times 12 divided by 4 divided by the R constant, 0.0821. If you type that in the calculator, 5.6 times 12 divided by 4 divided by 0.0821, you should get 204.6 Kelvin. Remember, your units for temperature for the ideal gas law is always going to be Kelvin all the time. Okay, so I'll do another one. That's number 1. So for number 1, once again, I'm grading on your work. I'm grading on your ability to plug the correct values in the correct spot in the equation. So what I'm looking for is this. That's what I'm looking for. That's what I'm grading on. Plug everything in correctly. The answers are on the bottom. That's so you can check your work. So I'll do number 2 for you, and then you're on your own for 3, 4, and 5. Number 2, if I have an unknown quantity of gas at a pressure of 121.6 kilopascals, a volume of 31 liters, and a temperature of 87 degrees Celsius, how many moles of gas do I have? Okay, so again, Pivnert, PV equals nRT. So let's see what we're going to plug in for pressure. Let's read it again. If I have an unknown quantity of gas at a pressure of 121.6 kilopascals, there it is, a pressure of 121.6 kilopascals. That's what we're going to plug in for our P. So I have 121.6 kilopascals. And then what about volume? What about volume? A volume of 31 liters. There it is, pretty explicit. 31 liters equal to, we have a temperature of 87 degrees Celsius. How many moles of gas do I have? So N is the next variable in our equation. N stands for number of moles of gas. So that is what we're solving for. We are solving for N. So which R value are we going to use? Once again, here's how you figure that out. Look at pressure. Look at your pressure. What is the unit of pressure? What is the unit of pressure? Kilopascals, kPa. So the R value that you use has to have kilopascals in its unit. So which R value has kilopascals in its unit? This one over here this time, 8.31. So we're going to plug in 8.31. Okay, the unit for R is simply liters times kilopascals over Kelvin times mole, okay? That's the unit. That's just a unit. That isn't an equation in and of itself. You're not going to plug in numbers for liters, kilopascals, or anything. That's just the unit. That's a common mistake. I've seen kiddos plug in numbers for liters. Okay? They'll put 31 right there. And then what was the volume you got for kilopascals? 121.6. I've seen kiddos plug in 121.6 right here for kilopascals. And they have kind of an equation within an equation. And it becomes this long expanded monstrosity. Okay, don't do that. This is just a unit. Leave it alone. That's just the unit. And then what's next? T, temperature. 87 degrees Celsius. Do not plug in 87 degrees Celsius. Remember, okay, it's a trick. What unit does your temperature always have to be in for the ideal gas equation? What unit? Kelvins. How do we get to Kelvin? We have degrees Celsius. How do we get to Kelvin? We have to add 273. So I'll do that longhand right here really quickly. So I have 87. We're adding 273. Okay, so that's going to be 10, 9, and 7, 16. So that's going to be 360. That's what we plug in. 360 Kelvin. 360 Kelvin. So there is your work for number 2. Again, if you want to check your work, look at the bottom. The answer is 1.26 moles for number 2. Type it into your calculator. If you do not get 1.26 moles, something went wrong. Double check your values. Okay? So we have on the calculator, you should type in 121.6 times 31 divided by 8.31 divided by 360. 121.6 times 31 divided by 8.31 divided by 360. That should give you 1.26. If it does not, you plugged something wrong in somewhere or you typed it into the calculator wrong. Double check your work. Alrighty? So I am going to leave you to it for numbers 3, 4, and 5. Okay, that is going to be due. Remember, I'm checking your work. Don't just put the answers. I'm going to mark it wrong. I'm not grading on your answers. I'm grading on your work. All right, kiddos? And thank you for watching. And happy, what is today? I'm forgetting the days. It's quarantine. All the days are blurring into one another. Today's Tuesday. Okay, I'll let you get to it. Happy Tuesday.